Okay, so we've got ourselves a little test set up, but this is a C++ course, not a Blueprint course, so it is about time that we converted this over so that then we'll have access to all our components in C++ and be able to program in some functionality such as attaching it to the tank. Now is a good time to convert over from this prototype that we've been doing. So the first thing we're going to have to do is create a base class in C++ and then derive a blueprint from it. Now I'm going to hold your hand on this bit because there will be a little bit of a hiccup that might catch you out. If you feel very confident, you can try and do this for yourself. What we want to do is create a base class that derives from actor and then create a blueprint class that derives from that. So then we can create default subobjects that represent both of the blocks here as well as the physics constraint. We want to do that all in C++. And then we want to migrate everything across. So let's begin. I'm going to go over to my Add New button in the content browser and create a new C++ class. It's going to be derived from actor. Go to Next, and I'm going to call it the sprung wheel because I'm thinking ahead a little bit. This is going to have a wheel. It doesn't at the moment. Let's go ahead and create that class. And while it is compiling, let me tell you a little bit more about what we're going to have to do, because we're going to set up this sprung wheel as a new blueprint, not as the existing thing that we've put together as a spring, mostly because there isn't much value left in that. It's just the configuration of the components, which we're going to have to copy over to a new blueprint anyway. There's no easy way to migrate that, sadly, in C++, in Unreal, and that's going to give us a bit of busy work, sadly. But let's go over to our content browser, to the content folder, and under tank is where I'm going to try and create my blueprint based off of that C++. If I go to Add New Blueprint Class and look under All Classes and look for the sprung wheel, there we go. I can go ahead and select the sprung wheel. Actually, that was easier than I thought. We didn't have any issues, unlike I was expecting. So we can go ahead and do a sprung wheel. It's going to be called _BP. And if we go ahead and open that up, it is a fairly straightforward actor class here, not very much going on at all. So we can go ahead and open up the C++ file over here, which it already has done for us. It's gone ahead and opened up the C++ file. And this is the place where you're going to set up your components. I just want to remind you how that's done. You've done it before in this project. If we go into the public of the projectile, for example, projectile.h, then you will see we've got ourselves a bunch of U properties here, such as the particle system component, the static mesh component, and all that sort of good stuff, which are pointers. And if we go over to the C++ of that projectile, then we are doing this create default sub object, we're setting up some properties, we are setting a root component, and we are doing attachment and good stuff like that. So that's basically what I want you to do. So let's see if you can create this base class to be the same as what we already had. So all components need to be default sub objects. We need to set up with the same root, we need to set up the attachment in the same way, and then you need to recreate the spring mechanism, which means unfortunately copying across all the properties from the old blueprint, but it's okay, going forward we won't have to do this. Okay, so pause the video and have a go at bringing it all across. Okay, welcome back. So we've got our example here. It's going to be fairly straightforward. So we've got the projectile.h is going to be our example for the U property. Let's bring that across to our header here. Actually, I'm going to make these private, and I'm going to call the section components like this, so it's really clear what I'm putting here, what U properties they are and why. So it's going to be a U static mesh component. It's not going to be a collision mesh. It's going to be the mass. I can initialize it as null pointer, and the category is components. That's fine. So I can go ahead and make a second one here, which is going to be the wheel, like so. And then I'm going to make a third one, finally, which is going to be a U physics component, physics constraint component. How would you have known that that was a thing apart from autocomplete? Well, because if you had gone into your constraint blueprint, your constraint test, open the blueprint editor, have a look at your physics constraint. If you hover over it, you can see that in brackets it says physics constraint component. Concatenate that together, put a U in front, that's what you've got. But you could also have searched through the documentation. So if I go ahead and open up my docs and I look for physics constraint component UE4, and I'm just going to append C++ at the end here, then you will probably quite quickly come to this documentation page, which is very, very useful, and it's also linked in the resources now. So you are going to have these properties, but we need to initialize them. So let's go over to our C++ and see how they're being initialized in the constructor of aProjectile. So we can copy over this create default subobject. I'm going to bring it over to my sprung wheels constructor. And we're going to be constructing, first of all, the mass, and the mass is going to be the root component. So I'm just going to make sure it has the right name. And then I'm going to do a set root component on this actor with that mass. And then the next thing we want to do is set up the wheel, which is going to be pretty much identical as a uStaticMesh component. I'm just going to call it wheel instead. And then we want that to be attached to the mass. So one way of doing this is in that C++ file with the attached to component. But a slightly better way, in the constructor only, is the only place you can do this, is with setup attachment. It's slightly shorter and it's slightly better when doing these kinds of setups within constructors for default subobjects. And then you can just pass the thing you want it to attach to. So the wheel attaches to the mass. That's basically what we're saying here. Okay, so what's the complaint here? Maybe it'll go away. Cannot be assigned to entity of type. I've probably given the wrong types around. Yes, this one's been called wheel when actually I wanted to call it something else. Maybe the physics constraint, or I'm going to call it the mass wheel constraint, just to be a little bit more obvious what that's trying to do. So now that shouldn't give us an error. And I can do a default sub-object also for our mass wheel constraint. Very, very similar, but there is going to be one little hiccup here, which should be, I need to change the type and create default sub-object. That's one thing, but that's not the hiccup. And I need to change the name of the F name as well. But again, that's not the hiccup. If I go ahead and build, let's see whether the hiccup actually happens or whether I'm just imagining that it will happen. Okay, I wasn't imagining it. There is an error in the build, and it is the use of undefined type physics constraint. You've probably seen these before, and you probably know, although if you'd forgotten, I'll forgive you, that you need to include the right header. And we can do this by going to the bottom of the documentation for the uPhysics constraint component, the type that it's complaining about. And we can look at the header down here. Now you can include the whole thing, or we can just include the last bit here, the bit that's kind of looks specialized. I don't quite know how I do it, but I think there's some rules, and you see if you see classes or engine and things like that, those are quite generic, whereas physics engine and physics constraint component seems quite specific. So I'm grabbing those. And then we're going to go ahead and do an include like this. And we've included our physics constraint component like so. So let's go ahead and build that now. Hopefully the physics constraint component is happy to build. Looks like it was. That's great. And we can go over to have a look at our blueprint child class. Open the full blueprint editor. And you can see that there is the full setup here, the full gamut of the mass, the wheel, the mass wheel constraint. Now the only thing that's missing is the actual component setup. So let's go ahead and put these two components side by side. And I'm going to go through bit by bit each one of these components and copy over their properties. Now this is going to be quite laborious, so I'll pause the video at some point and let you just do the copying if you haven't already. So let's first of all look at the mass. Now you can see that on the right hand side we've got a few things that are non-default. In fact, we can make this a little bit easier for ourselves by going to the little eye icon and doing show, let's see, show only modified properties. So this shows us only the things that are different from the default on this static mesh component. And I can click on a property and copy it and paste it over into my sprung wheel. So I'm going to go through and do this for all the non-default things. This seems like it is default, but maybe it's not. Let's go and have a look. Okay, physics actor, that one's got it as well. Now this may not get everything, so we have to be careful. So we'll just try it out, see how it goes. I think it's forgotten the mass, for example. That one didn't show up. So mass of 100 kilograms, that's what we need. But maybe that was the default anyway. Then we're going to look at the physics constraint next. So select the physics constraint in both places. And the component names I'm going to need to copy across. And so on. You can see what I'm doing here. So I'm just going to fast forward. You can pause the video and attempt this yourself. Okay, so I've gone ahead and applied that throughout. The only little hiccup you may have seen is that if you were showing only the changed properties, unfortunately the position target and velocity target wouldn't show up in that. So you may have missed those. Just draw your attention to the fact that those do need adding in, as well as the mass on the wheel. If any of that was hidden, that's not so great. Okay, so let's go ahead and save and compile that wheel. And what I'm going to do is I'm going to go ahead and bring it on in to the sprung wheel. In fact, I've just realized there's something I have forgotten to copy across, which is the transform of that wheel. So let's go and select the wheel, go up to the top, and here is the location. You probably didn't forget, I did. Let's go ahead and paste that one in. And if we go and pull the sprung wheel into our scene, then you can see that it is set up almost identically. And if I hit play, they both drop at the same rate. The suspension looks absolutely identical. So it looks like we have done a job well done of copying across and configuring the blueprint. So we've got our spring wheel ready, but now we have got access to all of these components in the C++. So we are ready to go forward. Thanks for bearing with me on that refactor, and I will see you in the next lecture.